Welcome to EGBT channel. Myself Ravi Kumar. Please subscribe our channel and share to your friends. In this video, I am discussing about the what are the voltage and current power equations in balanced star connected system, or what is the relationship between line as well as phase quantities. That is, what is the relation between line voltage and phase voltage, line current and phase current. Then we can derive the equations in balanced star system. First of all, we can draw the balanced star system. That is, consider the balanced star network you must draw. That is, we know the star connection here. That is, here we are considering the system is balanced. That means all voltages or the impedances in star connection are equal. Okay, this is the star connection. Then the lines are here. The supply star lines should be coming from supply here. That is the connection from supply to the load system. This is R, Y, B. So these are the three phases R, Y, B. Then the currents are, we are considered here IR, IY, IB. That is, all three currents IR, IY, IB are joined at a junction point, that is called neutral point. Then we are consider all impedances are equal. Then we consider the impedance of balanced star system, consider Z. Then what are the voltages? That is, this is R and Y. Between R and Phi, we are consider the voltage is V R Y. Between Y and B, we are consider the voltage is V Y B. Between R and B, we are consider the voltage is V B R. Okay, these are the different voltages we have in star system. Okay, after drawing the star system, then we have to derive the required equations. What are the phase equations? What are the line equations? From the star connection system, first of all, we have to consider what are the phase voltages. That is, the phase nothing but only R phase, VRN. The voltage in the R phase, that is from R to neutral. Similarly, VYN and similarly VBN. These are called the phase voltages. And consider line voltages. Line nothing but between the two phases, that is called line voltage. That is VRY, VYB, VBR. All are equal. So that is called, consider they are called the line voltages. VRN, VY1, VBN are called the phase voltages. Already we know in three phases all voltages That is, in balanced system, all voltages are equal but displaced by 120 degrees each other. Then what is the value of Vrn? That is, voltage is Vph. It is reference, that is 0 degrees. And similarly, what is the value of Vy1? That is Vph at an angle minus 120 degrees. Hence, what is the third voltage? That is Vbn, that is Vph at an angle minus 240 degrees. So, these are the phase voltages, each voltage displaced by 120 degrees each other. Okay. Then we know according to the vector sum, that is Vry equal to, how to write down, that is Vrn plus Vny. That is Vrn plus Vny, combining vector sum, that is we get the Vry. Then what is the value of Vrn? That is phase voltage at an angle 0 degrees plus here that is we have the value Vyn. That's why the vector will be reverse. That is Ny reverse into Vy1. Vyn, then Vph at an angle 0. We know the value of Vyn, that is Vph at an angle minus 120 degrees. Okay. Then all these values are converted into the equivalent rectangular form. That is, for Vph at an angle 0, then convert into the Vph plus J0 minus other term Vph, that is for minus 120 degrees, the real value is minus 0.5 Vph minus J 0.866 Vph. So, this is the rectangular form for corresponding minus 120 degrees polar form. Then simplify the equation Vph minus minus plus 0.5. Then common the Vph real term, we will get 1.5 Vph plus J0 J 0.866 Vph. Then this value Vph will be common. Then 1.5 plus J 0.866 convert into the equivalent polar form. Hence, we will get root 3 Vph at an angle 30 degrees. Okay. This is the Vry value. Then we consider similarly VL, that is the line voltage. When we can derive other voltage also, we will get the same values. That is between VYV and between VBR. The same values are we will get here. From the above relation, that is VL is called line voltage and VPH is called phase voltage. Then therefore, from the above relation, what is the relation between line voltage and phase voltage? That is line voltage equal to root 3 times phase voltage. Simply we can write down VL equal to root 3 VPH. So, this is the relation between line voltage and phase voltage. In case of star connection, VL equal to root 3 VPH. Similarly, when we are observing star connection here. In star connection, this is R phase. For R phase, we are considering the current is IR, then up to N. Similarly, this is the B phase, current considering IB, and Y phase current is IY. That is, there are no between the line currents. We are having only the phase currents. That means there is no connection between the lines. That's why in star connection, all line voltages are equal to all phase voltages. That means in star connection, the value of line current is equal to the value of phase current. That means IL equal to IR equal to IY equal to IB. All currents are equal here. Why? Because we are considering balanced system. That's why. But the relation between line current and phase current in case of star system is both are equal. Line current equal to the phase currents. Why? Because there is no connection between the lines. That's why all currents are equal. Similarly, we know the voltage value and we know the current values. Then what are the relations in power? That is, we know the types of power. The first one is active power, that is P. We know the relation is V I cos phi. By default, the current and voltages are phase values, VPH, IPH, cos phi. We know the value of VPH equal to root 3 into, that is, here this is the three phase system. Okay, VI cos phi is the single phase system. That's why for all three phases, total voltage is 3 into VPH, IPH, cos phi. From the above relations, we know VPH equal to VL by root 3, IPH equal to IL cos phi. Then root 3 term will be cancelled. The active power in case of three phase system is root 3 VL IL cos phi. So this is the active power formula in case of line values. In case of phase values, 3 VPH IPH cos phi. Similarly, same reactive power, total reactive power in three phase system. That is Q. Same analysis, root 3 VL IL sin phi. Same, the last power is apparent power. Apparent power, it is denoted by S, same root 3 VL into IL. So by default, the values, voltage values also given in the problems are the phase values. In the problems, especially mentioning the voltage is line, then it is taken as the line voltage. Otherwise, the voltage are given are phase voltages. Then convert into line voltages. Then by using formulas, root 3 VL IL cos phi is active power, root 3 VL IL sin phi reactive power, and root 3 into VL into IL apparent power. So all powers also we are calculating in case of star system. After calculating all values in star system or in any three phase system, very important here, you can first draw the phasor diagram of the system. In three phase system or in AC circuit, phasor diagram is very most important. How to draw the phasor diagram of the star system? So very important here. Then we know all three phase voltages are displaced by 120 degrees each other. Then I am considering VYB is reference and second one VRY and third one VBR. All three phase voltages are displaced by the 120 degrees. We know that. Then according to the phase relations, VL equal to root 3 VPH. What is the meaning that here? That is the current, and also the current relation is IL equal to IPH. Sir, that is if the current having phase angle phi, and what is the phase angle of voltage 30. That is what is the total phase angle difference between the voltage and currents 30 plus phi. Okay, and also the phase angle difference between the line voltage and phase voltage nothing but 30 degrees. That is with 30 degrees you can mention the values of line. Okay, VYB is the line voltages. Then you can mention the phase voltages. What are the phase voltages? VY1, VRN, VBN. Okay, na? How to obtain VYB? Already you can show here. According to this equation, that is VRY equal to VRN plus VNY with respect to the line and phase. By using neutral point, we are also developing the phase quantities. That is VYB, nothing but VYN plus VNB. Okay, na? Then for 30 degrees, you can draw V, suppose YN, consider VYN, and also same 30 degrees, we can draw VNB. Okay, both line values are placing 30 degrees. Okay. Then how to obtain VYB? Adding of VNB plus VYN, VY1 plus VNB. Then adding both vectors here. That is, this is the vector adding representation. Then both vectors are adding to each other, VY1, VYN plus VNB. Then you will get the phase voltage is VYB. The line voltage is VYB. In the same manner, you can also write down the other quantities. That is, for VRY, VRY is the line voltage. For VRY, what are the phase voltages? VRN and VYN. Okay, that is VRN plus VNY. Okay, na? Then you have to write it. Already we have the VYN is there. In the same manner, the vector will be reversed here. Same vector VYN will be reversed. Then what happened? It will be reverse quantity. That is minus will be obtained. Nothing but VNY. The vector becomes reverse. Okay. What is the other vector here? The other vector is VRN. Okay. Here also both are facing with 30 degrees. Hence, we will get the line voltage nothing but adding of phase vectors. Okay. In the same manner, VBR. How to obtain VBR? VBN plus VNR. Already we know the VNB is there. That VNB will be reverse. Hence, the vector will be reverse. Then it becomes VBN. Okay, what is the other vector? Already we know the VRN is there. That VRN also will be reverse. Then it will be obtained VNR. Hence, the vectors are should be added. Then you will get the line voltages. Okay, like that we can develop the phasor diagram of the any three-phase system. And also we have we know the current values here. This current will be between the VR by V by B. The current is IR. We know the current phase angle, consider phi angle. Similarly, this is considered IY and phase angle is phi. The total phase angle is between the line phase voltages and currents. Total phase angle is 30 plus phi. Okay, na? That is between the current and voltage. Total phase angle difference is 30 plus phi. Okay, na? Remember that point here. Total phase angle between voltage and current. Okay. Similarly, VBN, the current is considering IB with phase angle that phi. Consider phase angle of current is phi, and we know the phase angle between the line and phase 30 degrees. The total angle is 30 plus phi. Okay, like that you must develop the phasor diagram of the three-phase system also. Okay, in star connection, balanced star connection, the line voltage is equal to the root 3 times of the phase voltage, and the line current is equal to the phase current in star connection. And also you can calculate the all powers values, that is P equal to, in terms of line values, root 3 VL IL cos phi, and reactive power root 3 VL IL sin phi, and apparent power root 3 into VL into IL. So in case of phase values, the powers are 3 into V into I into cos phi. So by default, V and I are the phase quantities. And like that, after developing the all quantities, you must draw the phasor diagram. So the phasor diagram is very, very most important. You must draw the in examinations also, along with phase angles. Please subscribe our channel and share to your friends.